chapter 2 by the same author, Professor Sylvanus Thompson, on the chapter 2 interpretations of how he made it calculus made easy. Now in chapter 2 we have all different degrees of smallness, and he was talking about the fractions, the small fractions could affect to the whole of the items that we'll be taking into considerations. So for example, the variables is unknown, just like x, y, and z. Any variable that you could mention on that, then we could comprehend this one to differentiate by adding a differentials of dx and dy depending upon the variables. So we could add it up. And on the first portions, we have mentions about the use of d as an a little bit of that portion of that subject. Now we meant just like if we are differentiating a particular variable, just like say for example, say of x or y, shall we say a little portion of it could affect to the whole of that variable. Now say for example on this, you will be making about the degrees or the level of that smallness of how it could affect to the whole. Now, say for example, if we will be talking about in 1 hour, in 1 hour, as we would say, mathematicians would say, it's 60 minutes. And in a minute, we have 30 seconds, by the way. And it could affect on that depending upon of how you want it to be. And 24 hours, then we have to get this one from 60 minutes times 24 hours, then we could bring at this to 1,440 minutes. Then in 7 days, we have to 10,080 minutes. If we would sum it up and multiply that one to 7 days, then it could affect then the whole part of it. Say for example, if we will be talking about the 1% of that, if we will be getting the 10,080 for 7 days, we would add it up. It's just like a small portion of that. A small portion is just like a fraction. Say for example, if we will be dealing with 1%. 1% by the way is just like 1 over 100. It's just a fraction of that. Now if we will be on the second level, second order of that, we will consider 10,080. So we would be having a product, no? A result of the product that one of that multiply of this particular minutes in the second order, then it will result to 101,606 to 400 minutes of that. So if we will take a percent of it, it would result this one. It's just like approximation that for example it's 1,051,200 minutes. That the author translate described this one in a chronograph before in the 17th century. As I mentioned before, so many scholars, so many inventors just passed, and then so many of them are just passed. And chronograph is one of the timekeeping, a sort of a watch. No? It's used for timekeeping, determining of how the time will go throughout the day. And also it's very important timepiece for when navigating, especially when you are in the sea. No? So it means something. So when you are considering of that one, it gives 1,051,200 minutes when you are doing on that, getting of it. So exponentially, you will get something, so many millions of thousands of minutes out of it. So when you are subjecting this one to a little bit something of a minute, then you could add up. Although it would be negligible, but when you add it up by portion, it will become important, and it will not become negligible or not. So this is something, the level of the smallness of what the authors would like to point out on this. So this is the missing items that we have discovered. It's just like masterpiece of that, of this write-ups that has been endorsed or been passing it out. This scholarly work has been passing from generation to generations, and after this particular, and we are lucky enough to this Gutenberg, this non-profit organizations, this been passing for these e-books as passed to us here, and it's very fortunate, privilege to share this one also to you, so that you could lighten it up, perhaps, or I believe that you are also in trouble of determining or understanding how to cope up of this particular subject, particularly this calculus. Now, I'm talking about a percentage. When we are talking about the percentage, it meant to say that if we will be talking about x, particularly with time, if we will be determining how much time it will go, or a minute, then if we will determining this one, a certain particular, a little bit of this something will end up, if the minute could increase or not, or it will add it up or decrease something, then this particular letter, the differential, or a little bit, shall we say in layman's term, derivative or differential of this could mean dx. So dx on a percentage of this, it means something very similar of that layman's and scholarly term. So this one is on the degrees of smallness. Now another thing of this sample also is we could add it up, is the result of making the level of 100, if this percentage, shall we say, if we're making in the first order, what would be a little bit fractions that would do if we will say 1%. So 1%, as we say, it could be ERAP is 100. So to go on 1.01, no? It means something on that. Then so 1 over 100. This is the first degree term, first degree level of the smallness that we have. If we go to consider a 1%, a portion of x, shall we say. So if we add up this one, we try to get a portion of the second order of this 1%. We will subject this one to another of itself and the second order. This is a second order is a little bit. Shall we say on the derivative, so we have d over d. No? So just like dx. So let's, for example, this one. No? dx. Same on this one, these illustrations. Now, if we will subject this one to 100, 100 times 100, say, for example, 1 up to 100 to the second degree, exponent of the to the second order, then that would result this one to 1 over 10,000. Okay? Now, if we will subject the second order up to this, now we are talking about the degrees of how small this percentage would be subjected to itself on the third level, on the third degree. So for example, we will add it up, this portion, up to another on the third degree, third order. Okay? So that would result from 100 times 100 of itself, it would be 10 times 100, it would be 1 million. do you think it's negligible or not? But for say, it's a small fractions that would it have. It's very important when we say something in a minute. That could help much on that. So that would be on and on, on and on. For example, this one x, go like this. It would be n or goes to infinity. So that would be something that one that x, if we will be getting this one here, a small portion, then you see its amount would be bigger or not. So even something, if we will meet this particular letter on calculus, it means the same, we have to complement. We have to consider a portion of that item. So we have to feel it, the small fractions, the small portion, a little bit of something of that, whether it is increased or it completes our analysis. So this is the degrees of smallness as what of the authors shall per se, regardless of that. So even it doesn't say something that it would add of how many degrees, as long as it would be in order. So 1 over 110 to up to the 3, up to the 4th. No? Then will be a small quantity of the second order smallness. It depends upon if it would be regarded as is negligible or not. So what matters most is how we comprehend on that, of how it will add on the analysis, on the analogy, when we're talking about a particular expression, particular algebraic expressions of that. If we will be solving a particular variable. Now, we'll be talking about this smallness, the degrees of smallness. Now, about the x, how we could consider that. Let's say, for example, this. It has a possibility of it would increase the amount, or it would increase. Now, adding it up on that one, we will use of this particular expressions. This is the differentials. Meaning to say, it is a little bit something of this particular variable. So once we get this one here, x plus dx, means to say that we add up something. If we will consider this one up, then particularly if we with respect to y, or with respect to another front, that would be on the second order. So if this one is the first order, we will say something that on the second order, we will know exactly how that interact on the first comprehension, that first analogy. Okay? Now, are there any increment? When we say increment, adding something. Increment, it adds something. It adds value of this particular x. So this is what mathematician shall we say, this dx is a particular of a language that could be used in differentiating this particular expressions. When we say something a little bit of that one, so that the whole the whole of the variable could be determined. Say for example, if we'll be taking an analogy of that one on the second order, what would be the final outcome if we would mean something that x has something to do when we examine that one on the second order? Could we mean something in an algebraic expressions? Would it result something? Now let us see something on the second order. Let us solve this. Now, say for example, x plus dx. You see, this is the first order. Now, if we will go on the second order, we will subject itself to the second order. If it's raised to the exponent of second, then we will be solving that. What happened if this variable, a little bit of adding on, that's a little bit of something in that. On the first order, it's still the same on that. But when we do on the second order analogy, it has something. It produced something. Now let us solve this. X plus dy dx times this expression x plus dx. Then we say that x squared will go like this here. X times dx is only have the x dx. Then we say something, then we go the other, x dx. Then dx times dx is will have 1, we have the dx squared. Adding it up, we have x squared plus 2x dx plus dx squared. So this is the result of that, x squared plus dx. Now, this is the result of the x squared, and this is the result of the it's not negligible, the first order. This is the first order quantity. No, this is not negligible. So this is the result of the first order quantity when we are expressing this one here is x plus dx on the second order. Now, what would happen on this? This dx squared, this is the result of the third term. This is the first term, this is the second term, and this is the third term. Okay? Okay? Now, this is the result of a particular x is a little bit of something and a little bit of something.